Hello, Math130 students. We are going to pick up on page 1, section 5.1, finding the domain of a rational expression and simplifying rational expressions. So here, the rational expression is defined as a ratio of two polynomials. I think the most important thing about knowing fractions is that the denominator cannot be equal to 0. For example, if I just look at, 5 divided by 0, this is undefined. And the reason that's undefined is because the denominator is equal to 0. That can't happen. If you try to put this into your calculator, it says error, right? This is not good. So instead, we say this is the value for which it is undefined. So let's look at these examples. It says determine which values make a rational expression undefined. So here are my steps up above. It says for step number 1, set the denominator equal to 0. And you're just like, okay, well, I can do that. So if I'm going to be looking at the denominator, so it's 6x is equal to my denominator. So I want to make sure that's equal to 0 in order to find the value, which is going to make it undefined. So I'm going to have that 6, 0 is equal to 0. So if I divide both sides by a 6, I get that x is equal to 0. I'm like, okay, yeah, that makes sense. If 0 is equal to x, then 6 times 0 is equal to 0, and that's what makes my denominator undefined. Perfect. Now let's look at this denominator. We want to set this denominator also equal to 0, so I can figure out what values you can make this undefined. So I have my 7c minus 5 is equal to 0. So I'm going to add 5 to both sides. So that 7c is equal to a positive 5. Then I divide by 7, and I get that c is equal to a 5 over 7. So this 5/7, if I plug it into my original fraction, it will give me a 0 in the denominator, which would make it undefined. Now for number 3, same thing. I still want to set my denominator equal to 0. I just have to be careful because now I'm dealing with a degree 2. So I'm like, okay, 84x squared plus 76x plus 16 is equal to 0. So when I have that degree 2, then I know that I want to factor. And the first thing you always want to think about when you factor is the greatest common factor. Well, here 84, 76, and 16, all of those coefficients are even. So at the very least, I know it can be a 2. Can anything higher? Yeah, 4. 4 is the highest number that can divide each of those 3 numbers. So 4 is my GCF. So I'm going to have 84 divided by 4, which is my 21. Oops, let's write that a little bit nicer. 21x squared. And my 76 divided by 4 is 19x. And 16 divided by 4 is my positive 4. From here, there are 2 things you can do. You can either do the AC method, where you rewrite the middle terms to get your b's, or you can do the guess and check. And one method is just as valid as the other. It really just depends on your style. I'm going to go ahead and do the guess and check because you know what? Why not? So I'm going to try guess and check. So I'm going to try to go ahead and factor out this polynomial in here. So if I'm going to factor out that polynomial, I'm going to look at my first term. My first term is 21. So I know that's going to be 1 times 21 or 3 times 7. The next thing I want to look at is my last term, which is a 4. So that can be 1 times 4 or 2 times 2. So when I set up my parentheses, remember, I am going to guess and then check. So I don't know, for the first term, I'm going to try my 7x and my 3x. Now, for that last term, it could be 2 and 2, or it can be 1 and 4. I'm going to go ahead and just try my 4 and my 1. So now I'm going to check this. So to check it, I do my FOIL. So 7x times 3x is my 21x squared. 7 times 1 is my 7x. My inner is my 12x. And my last is 4. Can 7 and 12 combine together to give me a positive 19? It can, if they're both added. So now I know that this is factored correctly if these are both addition. And don't forget my greatest common factor, which was outside, is a 4. And I know that all of this is equal to 0. So I have 4 is equal to 0. 7x plus 4 is equal to 0. And 3x plus 1 is equal to 0. Well, for 4 equal to 0, that can't happen, so you leave that alone. Here I have a 7x is equal to a negative 4. So x is equal to a negative 4 over 7. And here I have 3x is equal to a negative 1. So x is equal to a negative 1/3. So now I have that x is equal to a negative 1/3 and x is equal to a negative 4 over 7. So that ends up becoming my final answer. Now what we want to do in page 2 is simplify these rational expressions. So looking at the first example, I want to simplify. And the first step, it says to factor both the numerator and denominator. Perfect, it's already factored. So now I'm going to cancel out my common factors. But what I'm going to do is I'm going to spread it out so I can really see what's going on. So I have my coefficients, which is a 9 and an 18. Then I have my a to the 5th and my a to the 8th. And I have my b to the 3 and b to the 1. So I think people can see the 9 and the 18 pretty clearly when I write it like this. I can say, well, 9 divided by 9 is 1, and 18 divided by 9 would be a 2. So my fraction here would be a 1/2. Now I'm going to deal with my a's. Well, think about your rules of exponent. So for your rules of exponents, if I were to have a to the 5th over a to the 8th, well, think about the literal. I have 1, 2, 3, 4, 5. And on the bottom, I have 1, 2, 3, 4, 5, 6, 7, 8, right? So you can think of them as canceling out, and you have 3 left over. So you have a to the 3 on the bottom, and everything cancels out in the numerator. Well, that's the same as saying a to the 8th minus a to the 5th. So you have your a to the 3rd. So you know that when you cancel these out, you have an a to the 3rd problem, an a to the 3rd exponent. Now, if I'm looking at my b's, well, 3 minus 1 will give me 2. So you can rewrite this as a b squared over 2a to the 3rd power. You can either keep the 1 in front of the b or not. It's really just preference if students like to see that 1 or not see that 1. Okay. Now for number 2, we are going to do a little bit more work, a little bit more involved, but it's going to be the same process. So the first thing we want to do is factor the numerator and the denominator if possible. So here, if I am going to factor this out, well, if I'm looking at these coefficients in my denominator, I can see that I have a greatest common factor of 2. So when I factor a 2 out, I'm left with an x, and 14 divided by 2 is 7. So that takes care of the denominator. Now, I really want to focus on that numerator. Here, I can factor using the AC method. And here, I like the AC method because that leading coefficient is 1. So I have my a is equal to 1, my b is equal to 3, and c is equal to negative 28. So up on top I have a negative 28 and a positive 3. So our multiples of 28 that are going to add up to 3 would be a negative 4 and a positive 7 adds to a positive 3. Oops, sorry there, guys. So once I have that, I know exactly what's going to go inside my parentheses because that leading coefficient is 1. So I'm going to rewrite this as my x minus 4 and my x plus 7. So now I can see that both top and bottom has an x plus 7 that I can cancel out. So now I'm going to rewrite this as an x minus 4 over my 2. And that is my answer, simplified as possible. And notice how I'm doing all of my scratch work over to the side. So if you need to do the AC method and draw it out or do your guess and check, always do it off to the side, either to the right, to the left, or have some scratch paper. Usually you just want to keep your work as organized and as neat as possible. So if you want to get messy, have a place where you're going to be messy. Now, looking at number 3, what's different about this is if I have a degree 3. So here, you're going to have to remember your rules of factoring. So for example, if I had my x3 minus y cubed, that would factor as an x minus y, x squared, plus xy, plus my y squared. I learned that from chapter 4 on how to factor polynomials or the difference of cubes and the sum of cubes. So we are going to rewrite this. So I have my p and I have my 3. And down at the bottom I have my p squared minus my 6p plus my 9. So now I know that my numerator is going to be p minus my 3, p squared plus 3p plus 9. And my denominator, if you're doing the AC method, well, your a times your c would be a positive 9, your b is a negative 6, so you need to rewrite this as negative 3 times negative 3 gives you a positive 9, and a negative 3 plus a negative 3 is a negative 6. So I have p minus 3 times my p minus 3, and the only reason I was able to do that is because that leading coefficient was 1. So now I see that one of the p minus 3's cancels top and bottom. So my final answer, p squared plus 3p plus 9 over p minus 3. And that will be your final answer. Now, moving on to number 4, what's different about this one is that you definitely want to make sure that you write in standard form. And if you're thinking, what the heck is standard form? That's writing it from biggest exponent to smallest. So here, if I were to have my 20 minus my 5x, if I'm rewriting in standard form, it would be a negative 5x plus 20. So I'm going to rewrite this as a negative 5x plus 20 over my x squared minus x minus 12. So here I can see my GCF in my numerator as a negative 5, so I'm left with an x minus a 4. Now, if I'm looking at my x squared minus x minus 12, if I were to do the AC method, I would have a negative 12 and a negative 1, which would give me a negative 4 and a positive 3. And the nice thing about this is because the leading coefficient is 1, I know exactly what's going to go inside my parentheses. I know it's going to be an x minus a 4 and an x plus a 3. So the x minus 4's get canceled out since it's the same on top and denominator. So I'm left with a negative 5 x plus 3 as my final answer. Okay, and that is the end of section 5.1. If you guys have any questions, please feel free to email me or the Math Success Center or our embedded tutor. Thank you.